Hello students, welcome to section 4.1 and 4.2, and today we are starting chapter 4 and we'll talk about triangles. So the objective for today, I can classify triangles and I can talk about angles in a triangle. So uh, triangles can be classified in two ways, by their angles or by their sides. Okay, how do we classify triangles by angles? Acute triangle. By definition, acute triangle, we have three acute angles, which means all angles measure less than 90 degrees, between 0 and 90. The next one is equiangular, okay, which means three congruent angles. So the angles here have the same measure. And in a few minutes, we'll talk about how big is each angle. The third case is obtuse triangle. Obtuse triangle has one obtuse angle. Later in the course, we'll talk about whether we can have two obtuse angles in a triangle. And probably the most important triangle is a right triangle with the one right angle. So in a right triangle, okay, obviously this is the right angle. This is called leg. This is also called leg. And the longest side is called hypotenuse. Okay, so this will be called hypotenuse, and just like in Pythagorean theorem, a squared plus b squared is equal to c squared. So again, how do we classify triangles by angles? Acute, equiangular, obtuse, and right. Okay, we can also classify triangles by their sides. Okay, uh, first we will talk about equilateral triangle. Equilateral triangle, three congruent sides. Next one is isosceles triangle. Okay, isosceles triangle, at least two congruent sides. And this is very important. At least two congruent sides. So that means if a triangle is equilateral, it's automatically isosceles. But the converse is false. If a triangle is isosceles, it doesn't mean it's equilateral. And the third type is scalene triangle. In a scalene triangle, all sides have different lengths. In other words, no congruent sides. Okay, uh, in an isosceles triangle, okay, this is called leg. The two equal sides, the two congruent sides are called legs. This one is called base. And the two arrows you see, they are called base angles. Okay, base angles. And again, we'll talk about isosceles triangle at the end of chapter 4. So how do we classify triangles by sides? Equilateral, isosceles, and scalene. So please memorize the definitions. Okay, so let's practice a little bit. Determine if the indicated triangles are equilateral, isosceles, scalene, or right. Okay, and we know that CF, so this segment bisects BD. So in other words, this side is equal to this side. So DF is equal to 6, therefore this is also equal to 6. So first question, triangle AEB. AEB. So AEB is this one. Okay? So triangle AEB would be isosceles because this side is 6, this is 6, so that would be isosceles. Okay? The next question is triangle DAE. DAE. Triangle DAE would be scalene. And the last one is triangle DCB. DCB, which is the big one. okay? And the big triangle would be equilateral because each side is 12 units. Okay, so what I recommend right now doing is pause the video, try this example, and then watch me doing it. So classify the following triangles as obtuse, acute, equiangular, or right. So the first one is triangle AEC. AEC. Triangle AEC is the big triangle, okay? And each angle is 60, therefore is equiangular. Question B, triangle ADC. ADC, I am talking about this triangle. Okay, so we have 60. This angle here would be 90 because 70 plus 20 is 90, and 30, therefore it's a right triangle. And question C, triangle DCB. DCB, which is this one, is red. That's obtuse. And question D, triangle DAB. Let me use blue. DAB, DAB, which is this one, and this one is acute because all angles measure less than 90 degrees. Okay, so before we talk about triangle sum theorem, which is the most important theorem in this chapter, let me do a little investigation using GeoGebra. Okay, so when you come to class, we'll talk about this again, but please take a look at this website. Okay, so I have a triangle. What's 84 degrees plus 52 plus 44? Again, what's 84 plus 52 plus 44? In other words, I'm talking about the sum of the interior angles in a triangle. The answer is 180. Now watch, I'm gonna move this triangle, okay? And the angles are changing. What's 38 degrees plus 26 plus 115? Interesting, also 180 degrees. If I move it again, 78 plus 57 plus 44 is also 180 degrees. So what is the point? The point is that the sum of the interior angles in a triangle is always 180 degrees, okay? So this is very, very important. The sum of the measures of the angles in a triangle is 180 degrees, okay? I want to just mention interior angles, because the exterior angle theorem we'll talk about in class, but the sum of the measures of the interior angles in a triangle is always equal to 180 degrees. In other words, angle A plus angle B plus angle C is equal to 180 degrees. Okay? So now, let's practice. What type of triangle is ABC? Please look at the tick marks. Okay? So we have two equal sides. So this triangle is automatically isosceles, but it could be equilateral if all the sides are the same. So first thing you will do, 3x plus 3 is equal to 4x minus 4. Subtract 3x, subtract 3x, so you get x, and put 4 on the other side, x is equal to 7. Okay, so x is equal to 7. Now let's substitute and find the length of each side. 4 times 7 is 28. 28 minus 4 is 24. 3 times 7 is 21. 21 plus 3 is 24. Okay, and now let's look at this side. X squared, 7 times 7 is 49. 49 minus 25 is 24. Okay, so each side is 24 units long. Therefore, this triangle is equilateral. Okay, please pause this video and try the example below. What type of triangle is DF? Again, in this example, we are talking about angles. Okay, what did we learn a few minutes ago? That the interior angles always add up to 180 degrees. Therefore, you will write x plus 5 plus 6x plus 2x minus 5 is equal to 180. Okay, x plus 6x plus 2x is 9x. 5 and negative 5, they cancel each other, equals 180. 180 divided by 9 is 20. So x is equal to 20. Now let's substitute. 20 plus 5 would be 25. 6 times 20 is 120. Okay, now one way to find angle F, 120 plus 25 is 145, and 145 plus 35 is equal to 180. So it's 35, but let's check it. 2 times 20 is 40, 40 minus 5 is 35. So how would you classify this triangle by angles? The answer is obtuse. Okay, why obtuse? Because we have one angle that measures 120 degrees. Okay, and let's just do this activity and we'll continue in the classroom. So find the measure of each number angle. You don't have to go in order, angle 1, angle 2, angle 3, angle 4, 5, 6, 7. Okay, but you can just look at this picture. So if you look at this triangle, okay, 66, 44, I can find angle 2 easily. Okay, the three angles are up to 180 degrees. So 66 plus 44 would be 110, and 110 plus angle 2 should equal to 180 degrees. So this is 70. Okay, so angle 2 would be 70 degrees. If you look at angle 3 and angle 2, okay, this pair, they form a linear pair. Therefore, angle 3 has to be 110. Okay, so angle 3 would be 110 degrees. Now, take a look at angle 1. So, if you look at this triangle, this obtuse triangle, 22 plus 110, that would be 132. And 180 minus 132 would be 48. Okay, so this angle is 48 degrees. And we just found angle 1, angle 2, angle 3. Okay, now where is angle 4? Well, angle 4, I don't know why I have angle 4. All right, now let's take a look at the bottom picture. Okay, what I just told you, that angle 7 is congruent to angle 8. Okay, if this angle is 40, how big is angle 6? The answer is 140, because they form a linear pair. So angle 6 is 140 degrees. Okay, we can also find angle 5 easily. Angle 5 plus 90 plus 40 equals 180 degrees. Therefore, angle 5 is equal to 50. Okay, now what about angle 7 and angle 8? If you look at this picture, this triangle is obtuse. We know that Angle 7 plus angle 8 plus 140 degrees should add up to 180. Therefore, angle 7 and angle 8 are up to 40, because 40 plus 140 is equal to 180. So angle 7 plus angle 8 is equal to 40 degrees. But they are the same, okay, because they are congruent because of the arcs. Therefore, they are 20 each. Okay, so angle 7 is 20, and angle 8 is also 20. Okay, so thank you for watching this video, and again, in class, we'll elaborate this. Have a good day.